Hello students, today let us discuss the topic errors in measurements. So when performing physical measurement, it is very important to note that the measurements obtained are not completely accurate. They are always associated with some uncertainties. So in order to analyze the measurement data, we need to understand the nature of errors which are associated with measurements. While performing physical measurements, we must note that the measurements obtained are not accurate. There is uncertainty associated with it. So in order to analyze the measurement data, we need to understand the nature of the errors associated with it. So that is why it is very important to investigate the causes or sources of errors in measurement system and also to find the ways to eliminate these errors. So two broad categories of errors in measurement have been identified. So there are two types of errors, that is systematic errors or controllable errors and random errors. So when you are making any physical measurement, we have to note that this measurement or the result which we are obtaining is not 100% accurate. There is some uncertainty or there are some errors which are associated with this measurement. So we should know the nature of these errors so that we can avoid such errors and get almost accurate results. It is important to investigate the causes of errors in measurement and find out ways to eliminate them. So two categories of errors in measurement. The first one, systematic errors, or we can say the other name for systematic errors is controllable errors. The second one is the random errors. So systematic or controllable error is a type of error that deviates by a fixed amount from the true value of measurement. So the first one, that is the systematic error, is a type of error that deviates by a fixed amount from the true value of measurements. So these type of errors can be controlled both in magnitude and direction. and they can be accessed and minimized if efforts are made to analyze them. So these type of error, that is the systematic errors, can be controllable in both magnitude and direction, and can be accessed and minimized if efforts are made to analyze them. So these errors can be accessed, that is, we can identify these errors, and if efforts are made, we can minimize them and control them. So in order to access them, it is important to know all the sources of such errors, and if their algebraic sum is significant with respect to the manufacturing tolerance, necessary allowance should be provided to the measured size of the workpiece. So now if there is some error caused in a component, so we have to know the sources of these errors. For example, if the size of the component must be some 500 mm, but it is only 450 mm. So why this size is only 450 mm? Why this error is caused? So maybe because the material which we are using is not proper, or maybe because the machining method is not proper, or maybe because the component which we are machining in the specified conditions like temperature, pressure. So all these may be the causes or sources of this error. So we have to identify these sources, and if the algebraic sum of these errors is significant with respect to the manufacturing tolerance. So here it is 450 and tolerance is given only till 480 mm. So if all these errors or the sources of errors are causing difference in the tolerance, a lot of difference in the tolerance, so here we can see it is not acceptable. This size is not acceptable. So then what should be done? Necessary allowance should be provided to the measured size of the workpiece. So here what is the allowance which we are providing here is, we will change the material, we will change the machining process, or we will change the machine on which this workpiece is being machined, or we may change the conditions like temperature, pressure, and such allowance is provided so as to reach this tolerance which is acceptable. So in order to access the sources of errors must be known, and if their algebraic sum is significant with respect to manufacturing tolerance, then necessary allowance should be provided to the measured size of workpiece. So when systematic errors obtained are minimum, the measurement is said to be extremely accurate. So when systematic errors are minimum, the measurement or the result which we are obtaining is accurate. But it is difficult to identify systematic errors and statistical analysis cannot be performed. Systematic errors can be eliminating by taking a large number of readings and then averaging them out. How these systematic errors can be identified? It is difficult to identify the systematic errors, and these errors cannot be eliminated by taking large number of readings and then averaging them out. So these errors are reproducible inaccuracies that are consistently in the same directions. So these errors are reproducible inaccuracies that are consistently in same direction. So they act in the same direction. So minimizing these systematic errors will increase the accuracy of the measurement. So why does these systematic errors occur? So are the causes of or reasons for the occurrence of systematic errors. So reasons for occurrence of systematic errors. So the first one is the calibration errors. The second one is ambient conditions. The third one is deformation of workpiece. The fourth one is avoidable errors. So we will discuss them one by one. The first, that is the calibration error or calibration errors. So a small amount of variation from the nominal value will be present in the actual length standards, as in slip gauges and engraved scales. So there will be small variation from the nominal value, or the standard value will always be present in the actual length standards, as in the slip gauges and the engraved scales. So inertia of the instrument and its hysteresis effect do not allow the instrument to translate with true fidelity. So a small amount of variation from the nominal value will be present in the actual length standards, as in slip gauges and engraved scales. So when you are measuring with the help of slip gauges or engraved scales, there will be some variation from the nominal value to the actual standards. For example, if you are using a scale to measure the length, so the actual standard may be 5 centimeter, but you will get a value of 4.99 centimeter, not the exact value. So there will always be some variation in the nominal value from that of the actual standard values. So why is that there is variation? So the inertia of the instrument, so there will be some inertia in the instrument and its hysteresis effect will not allow the instrument to translate with the true fidelity. So if the instrument has some 15 centimeter length, then the measured length, or the when you are measuring the same 15 centimeter, you will not get the exact value, you will get some 14.99. So why this is caused? Because there is some hysteresis and inertia effect of the instrument, which will not allow the instrument to translate to or translate with the true fidelity. So inertia and hysteresis effect of the instrument does not allow it to translate to its true fidelity. Hysteresis is defined as the difference between the indication of the measured instrument when the value of the quantity is measured in both ascending and descending order. So, hysteresis is difference between the indication of instrument when the value of the quantity is measured in both ascending and descending orders. So these variations have positive significance for higher order accuracy achievement. So calibration curves are used to minimize such variations. So these variations will have positive significance, that is the hysteresis effect has positive significance for higher order accuracy achievement. The calibration curves are used to minimize the such variations. So inadequate amplification of the instrument also affects the accuracy. So calibration curves are used to minimize such variations. And inadequate amplification of instrument also affects the accuracy. So this is about the calibration errors. The next type of causes for systematic errors is ambient conditions. So ambient conditions is nothing but the atmospheric conditions. So it is very important to maintain the ambient conditions at internationally accepted values of standard temperature and pressure conditions. So it is important to maintain ambient conditions at standard temperature, that is 20 degrees Celsius, and pressure, that is 760 mm of mercury, which is internationally accepted values. So a small difference of 10 mm of mercury can cause errors in the measured size of the component. So if there is a pressure difference or small difference of 10 mm, mercury will also cause error in the measured size of the component. A small difference of 10 mm Hg can cause errors in the size or the errors in the measured size of the component. But the most significant ambient condition which is affecting the accuracy of the measurement is the temperature. So temperature is most significant ambient condition which affects the measurements. So increase in temperature of 1 degree Celsius will result in increase in length of a steel by 0.3 micrometer, and this is substantial when precision measurement is required. So if temperature is increased by 1 degree Celsius, then if you are using steel, that is C25 steel, its size or its length will increase by 0.3 micrometer. So which is a big change when you want precision measurement. When you want exact measurement, then we have to maintain the temperature. That is what it is implying. Then the length of steel C25 will increase by 0.3 micrometer, which is substantial when precision measurement is required. So in order to obtain error-free result, a correction factor for temperature has to be provided. That is, we have to maintain the temperature. So in order to obtain error-free results, we must maintain the temperature according to standards. So thermal expansion occurs due to heat radiation from different sources such as light, sunlight, and body temperature of the operator also. So we have to keep in mind all the factors which are increasing the temperature or which are causing thermal expansion, and we need to control them so that we can avoid these ambient conditions which are causing the systematic errors. The next one is that is the factors which are affecting the or which are causing the systematic error. The next factor is the deformation of workpiece. So any elastic body when subjected to load will undergo elastic deformation. So we know that when you are subjecting a body, that is the elastic body, to load, it will undergo deformation, that is it will change its size or shape. Any elastic body when subjected to load will undergo deformation, that is elastic deformation. So the stylus pressure which is applied on the workpiece during the measurement will affect the accuracy of measurement. So when we are applying some pressure with the help of a stylus, so that pressure which is applied during the measurement will affect the accuracy of the measurement. Stylus pressure applied during measurement will affect the accuracy of the measurement. So due to definite stylus pressure, elastic deformation of the workpiece and the deflection of the workpiece shape may occur. So due to definite stylus pressure, elastic deformation of the workpiece and deflection of workpiece shape may occur. So the magnitude of the deformation depends on the applied load, area of contact and mechanical properties of the given workpiece. So when you are applying, so let us consider this as the workpiece and this is the stylus. So if this is the actual shape of the workpiece, so this is the workpiece. When pressure is applied from the stylus, then what happens? This stylus will enter till this position and the shape of this stylus may be engraved in this workpiece. So that is nothing but this is the deformation of the workpiece. So the magnitude of the deformation will depend on the load applied and the area of contact. So this is the area of contact and also the mechanical properties of the material of the given workpiece. So it will depend on the load, the area of contact between the stylus and the workpiece and the mechanical properties of this material of the workpiece. So when you are applying the load, you have to be careful so as to check for the deformation of the workpiece. The next type of errors are avoidable errors. So these errors also cause systematic errors. So avoidable errors include different type of errors and they are, first one is the datum error. So datum error is the difference between the true value of the quantity being measured and the indicated value with due regard to the sign of each. So datum error is nothing but it is the difference between the true value and the indicated value with due regard to the sign of each. For example, if you are measuring a quantity of 500 gram. Now the indication for this quantity is showing as 499 gram, not 500 gram. So the difference between these two, that is 500 minus 499, is the datum error with regard to the sign. It may be positive or negative also. Is the difference between the true value of the quantity being measured and the indicated value with due regard to the sign of each. So when the instrument is used under specified conditions and a physical quantity is presented for the purpose of verifying the setting, the indication error is referred to as the datum error. So we can simply say that this datum error is the indication error caused by the instrument, so which is not indicating the correct result. The next one is the reading errors. So these errors occurs due to the mistakes committed by the observer while noting down the values of the quantity being measured. So the person who is taking the readings, he may commit mistakes and he may take a wrong reading. So that is the reading error. So these errors occur due to the mistakes committed by the observer while noting down values of the quantity being measured. So digital readout devices, which are increasingly being used for display purpose, eliminate or minimize most of the reading errors usually made by the observer. So with the help of digital readouts, so digital displays or displays can reduce or eliminate these errors. So if there is some digital output or digital display, we can see the readings directly and note them down. Otherwise, manually there might be mistakes when there is indication on a scale. So these errors can be eliminated by digital readouts. Now the next one is the errors due to parallax effect. So parallax errors occur when the sight is not perpendicular to the instrument scale or the observer reads the instrument from an angle. So if this is the instrument scale, the person who is taking down the readings must see it from the direction perpendicular to the instrument scale. If he is viewing it from some angle, he is not seeing it directly but from some angle, then parallax errors are caused and he may not take down the readings correctly. So parallax Errors occur when the sight is not perpendicular to the instrument scale, or the observer reads the instrument from an angle. So instrument which are having a scale or a pointer will normally associate with this type of errors. So the presence of mirror behind the pointer or the indicator will virtually eliminate the occurrence of this type of error. For a simple solution to reduce this parallax effect is keeping a mirror behind the scale or the indicator. So the instruments with pointer and scale are associated with this type of errors. To eliminate these errors, a mirror can be placed behind the pointer or indicator. So this is about the parallax effect errors. The next type of error is effect of misalignment. So these errors or misalignment occur due to inherent inaccuracies present in the measuring instrument. Occur due to inaccuracies present in the measuring instrument. So these errors may occur due to improper use, handling or selection of instrument. So if we handle the instrument improperly or improperly we are using the instrument, or if you are selecting the wrong instrument, then these errors will occur. So these errors may occur due to improper use, handling and selection of instrument. So where on the micrometer anvil, so effect of misalignment may be caused, or the misalignment may be caused when wear on the micrometer anvil, or when the anvil faces are not perpendicular to the axis. So misalignment may be due to wear on the micrometer anvil, or when the anvil faces are not perpendicular to the axis. So because of these misalignments, there will be inaccurate measurements, so leading to inaccurate measurements. So if the alignment is not proper, sometimes sine and cosine errors are also caused because of misalignments. or if there is no proper alignment, and they will also cause inaccuracies in measurement. Sine and cosine errors caused due to improper alignment also contribute to inaccuracies in measurements. The next type of avoidable errors is the zero errors. Zero errors. So when no measurement is being carried out, the readings on the scale of the instrument should be 0. So you might have noticed there is a notice written on especially the petrol bunks to ensure 0 before the person pours the petrol in your petrol tank. So why this 0 has to be ensured? So if not, what happens is the initial value, if it is not 0 or if it is some other reading, then the reading will start from that reading and you may get less petrol and he may collect more money. So that is why you have to ensure 0 before the person loads petrol in your vehicle. So when no measurements are carried out, the reading on the scale of the instrument should be 0. So the 0 error is defined as the value when the initial value of the physical quantity indicated by the measuring instrument is non-zero when it should have actually been 0. So 0 error can be defined as that value when the initial value of a physical quantity indicated by the measuring instrument is a non-zero value when it should have been actually been 0. So as soon as you keep this physical quantity to measure in a measuring instrument, the initial value must be 0. If it is not 0, then such value is called as the 0 error. This error is constant for all the values measured using the same instrument. This error is constant for all the values measured using the same instrument. So here this error, that is the 0 error, is constant for all the values which we are measuring using the same instrument. Now the constant error affects all measurements in the measuring process by the same amount. So this constant error affects all the measurements in a measuring process by the same amount. Or we can say that an amount proportional to the magnitude of the quantity being measured. So, in order to find out or eliminate systematic errors, we have to calibrate the measuring instrument before we are conducting any experiment. So, we have seen that all these avoidable errors, that is the datum error, reading error, errors due to parallax effect, effect of misalignment, and zero errors, these are all causes or sources for systematic errors. So if you want to eliminate these systematic errors from your measuring instrument, then we need to calibrate the measuring instrument before we are carrying out any experiment. So, to find and eliminate these systematic errors, it is required to calibrate the measuring instrument before conducting an experiment. So, calibration reveals the presence of systematic errors in the measuring instrument. So, how does calibration help? Calibration will reveal the presence of systematic errors in the measuring instrument. So, once we are able to find these errors, we can eliminate them. So, the second type of errors are the random errors. So, what are random errors? So, random errors provide measure of random deviation when measurements of a physical quantity are carried out repeatedly. So, they will provide the measure of random deviations. So, when we are conducting the measurement again and again or repeatedly, these random errors will provide the random deviations of a physical quantity. The measurement of physical quantity will vary randomly, so they will provide these random variations. So these errors provide a measure of random deviations when measurements of a physical quantity are carried out repeatedly. So, when a series of repeated measurements are made on the component under similar conditions, the values of the results of measurements will vary. So, when we are carrying out measurements repeatedly or again and again, and there are a series of measurements carried out, then the values of the measured quantity will vary, or the results of the measurements will keep on varying. So, when a series of repeated measurements are made on a component under specific conditions, the values of the measurements vary. So we cannot determine the specific causes for these variations. So these variations are unpredictable and uncontrollable by the experiment, and they are random in nature. That is why we cannot determine the causes for these variation. Specific causes for these variations cannot be determined as they are uncontrollable and unpredictable by the experimenter, and they are random in nature. So we cannot determine the causes for these variation because they are not controllable, and we cannot predict these causes as they are random in nature. So they are of variable magnitude and they may be either positive or negative. So the magnitude of these errors will be varying and they may be either positive or negative. So when these repeated measurements are plotted, they will follow a normal or Gaussian distribution. So when plotted, these repeated measurements will follow normal or Gaussian distribution. But these random errors can be statistically evaluated and the values of their mean and standard deviation can be determined. So these random variations or random errors can be statistically evaluated and their mean and standard deviation values can be calculated. So these errors scatter around a mean value. So if we are making n number of measurements using an instrument, let us denote those measurements as V1, V2, V3 and so on up to Vn. Then the arithmetic mean is given by, so if n number of measurements are made using the same instrument, using an instrument, let us denote the measurements as V1, V2, V3 and so on up till Vn. Then the arithmetic mean is given by V bar is equals to V1 plus V2 plus V3 plus so on plus Vn up till Vn divided by the number of measurements, that is n. Now standard deviation is given as sigma is equals to plus or minus summation of V minus V bar whole square divided by n. Now for different types of readings, how do we write the standard deviation? So standard deviation is the measure of dispersion of a set of readings. So standard deviation is a measure of dispersion of a set of readings. So now we can determine it with the help of this formula. Sigma is equals to plus or minus root of summation of V1 minus V bar whole square plus V2 minus V bar whole square plus so on plus Vn minus V bar whole square all divided by n. So these random errors can be minimized by calculating the average of a large number of observations. So if you want to minimize the random errors, you can make repeated calculations, or you can take repeated readings and then you have to calculate the average of these readings. So since precision is associated with the repeatability of a measuring instrument, a precise instrument will have very few random errors and better repeatability. So a precise instrument will have very few random errors and better repeatability. So from this statement we can say that random errors will limit the precision of the instrument. So if the precision must be more, random errors must be less. That means if random errors are more, then the instrument will not be precise. So now what are the sources of these random errors? So sources of or causes for random errors. So the first one is presence of transient fluctuations in the friction in the measuring instrument. So if there is any friction present in the measuring instrument, then it will cause random errors. Fluctuations in the friction will cause random errors. The second one is play in the linkages of the measuring instrument. So if there is any disturbance in the linkages of the measuring instrument, then it will cause random errors. The third cause for random errors in the operator's judgment in reading the fractional part of the engraved scale division. So if there is a scale and there are some readings on this scale, the person who is taking the readings or the operator, he may get mistake or he may have error in reading the fractional part of this reading. So if the scale is somewhere here, so how does he take the reading? So he has to take the fractional part into consideration. If he is not taking the fractional part into consideration, then there will be error, and that is a random error. The fourth cause or the fourth source of random errors is the positional errors associated with the measured object and the standard, arising due to small variations in the setting. So while setting the component, if there is any positional error, then it will cause the random errors. So even for the small variations in the settings also, these errors, that is the random errors, will be caused. So now, difference between systematic errors and random errors. So we have learnt that there are two different types of errors in measurement, that is the systematic errors and the random errors. Now we will see the difference between these two errors. Systematic and random errors. So I am making the partition between these two errors. So the first difference is systematic errors cannot be detected easily, but random errors can be detected easily. So not easy to detect. Random errors are easily detected. Systematic errors cannot be eliminated by repeated measurements. So even if you are making many number of measurements, these systematic errors cannot be eliminated. Random errors can be minimized by repeated measurements. So you can minimize these random errors if you are making repeated measurements. Systematic errors can be accessed easily, or we can find these systematic errors easily. Random errors cannot be accessed easily. They will require statistical analysis for accessing them. So requires statistical analysis for accessing. So when we minimize these systematic errors, we will be able to increase the accuracy of measurements. So minimizing systematic errors will increase the accuracy of measurement. So minimizing random errors will increase repeatability, and that is why the precision of the measurement will increase. So minimizing random errors increases the repeatability and hence the precision of the instrument. So here accuracy will increase when systematic errors decrease. Here when random errors decrease, precision will increase. The fifth point says that calibration helps to reduce systematic errors. But calibration has no effect on random errors. Even if you calibrate the instrument, random errors still occur. The sixth difference between the systematic and random errors is that characterization of these errors is not necessary. But random errors must be characterized by mean, standard deviation, and variance. Mean, standard deviation, and variance. So because we can access them only through statistical analysis, we have to characterize these random errors. The seventh and the last difference between these two type of errors is that reproducible inaccuracies that are consistent in the same direction. So systematic errors will have reproducible inaccuracies which are consistent or which are produced again and again in the same direction. So these type of errors are random in nature and can be both positive and negative. So here you can see it is only in the same direction, but here it may be either positive or negative, so varying in both the directions, and can be both positive and negative. So in systematic errors, it may, if it is in the positive direction, it will be in that direction itself. If it is in the negative direction, it will go on in the same direction. But here in random errors, it may be either positive or negative as they are random. So this is all about errors in measurement. I hope you have got the topic. Thank you.